Thanks for tuning in for another episode of Math with Mullins. We are going to be looking at 7.5 properties of trapezoids and kites to be able to determine what theorems we can use with them and be able to use those properties. First thing we want to know are what is a trapezoid. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. The bases are those parallel sides, legs are the non-parallel sides, and an isosceles trapezoid is a trapezoid with congruent legs. So if I were to draw a trapezoid, this would be an example of one, maybe with an isosceles one where you have matching legs and you have your pair of parallel sides, top and bottom. We also have a theorem to look at here. So this is on your theorem sheet 7.14. The isosceles trapezoids base angles theorem just states if the trapezoid is an isosceles trapezoid, then each pair of base angles is congruent. So this would be a good picture to draw on your theorems worksheet because you only have the theorem. Picture kind of helps you visualize it. If the trapezoid ABCD is isosceles, then A matches D and B would then match C. So base angles meaning both top and bottom where you're seeing your parallel sides, only in isosceles trapezoids. The base angles converse for isosceles trapezoids just means if a trapezoid has a pair of congruent base angles, then we can prove that it is an isosceles trapezoid. So again, drawing this picture here would help us understand where that needs to be located. And then the final theorem we're going to talk about before trying an example is the 7.16 isosceles trapezoids diagonal theorem, and that just states if a trapezoid is isosceles, if and only if its diagonals are congruent. So that's just an interesting fact to know about some isosceles trapezoids. Okay. So what we're going to do here is it says show that ABCD is a trapezoid and decide whether it is isosceles. The first thing we want to know is all of the slopes for the different sides. So I have AB, I have BC, I have CD, and then I have AD. Okay, for AB, I rise 1, 2, 3, 4, run 2, so that's 4 over 2, which is equal to 2. My slope of BC, I go down 1 over 1, 2, 3, so that's negative 1/3. CD, I go down 1, 2, 3, 4, 5 over 1, so that's negative 5. And then AD, I go down 1, 2 over 1, 2, 3, 4, 5, 6. Okay, sorry, I should go down 2 over 6. So negative 2, 6, which is equal to negative 1/3. So notice that BC and AD are parallel. Okay, so because of that, we can say that ABCD is a trapezoid because it has one pair of parallel sides. Okay, then we want to see if it is an isosceles triangle. So that means I need to find the distance, isosceles trapezoid, not triangle, the distance of the non-base, which would be AB and which would be CD. So AB's distance, I would do 0 minus negative 2 squared plus 3 minus negative 1 squared, 2 squared, 4 squared. That'll give me 4 and 16, or the square root of 20. Let's see if CD matches that. CD, I would do 3 minus 4 squared plus 2 minus negative 3 squared. That'll be negative 1 squared plus 5 squared. 1 plus 5 is 26. These are not matching, so it is not isosceles. So all I did is I used the distance formula for that. Okay. Next up, if ABCD is an isosceles trapezoid and the measure of A is 42, then find the measurements of B, C, and D. Well, using that theorem we just talked about, the isosceles trapezoid base angles theorem, if the trapezoid is isosceles, then each pair of base angles is congruent. So that means A and D should match with 42 degrees. I don't know what B and C are. Those are going to be a little bit different. So what I would maybe look at is I know this is a four-sided figure, so it has to have 360. So I would subtract 42 from 360. That's 318 minus another 42. I'm going to get 276. So then I have to split that between two even angles, and I'm going to get 138 degrees. So angle B is 138, angle C is also 138, because those are going to be your base angles as well. All right, in exercises 2 and 3, use trapezoid EFGH. If EG is equal to FH, is trapezoid EFGH isosceles? Explain. We would have to say yes here, because the theorem of by the isosceles trapezoid diagonals theorem. Okay, and then it says if HEF, so this corner, is 70 and FGH is 110, could this be an isosceles triangle or trapezoid? Explain. We could say yes, due to the consecutive interior angles. So GFE could also be 70 degrees, and GHE could be 110 degrees. And if we use the isosceles trapezoid base angles converse to say it's isosceles. Okay. We've got mid-segment of a trapezoid next. So the mid-segment is a segment that connects the midpoints of the leg. So MN is showing that mid-segment here. And we can find that by adding AB and CD together and then just finding half of that. So for example, let's say AB, I'm just gonna make up some numbers. If AB is 4 and CD is 10, I could say 4 plus 10 is 14, and then divide that by 2. The mid-segment would then have to be 7, okay? So make sure we have that filled in on our mid-segment or our theorem sheet as well, so we can go ahead and try some questions next. So the diagram MN shows the mid-segment of the trapezoid PQRS. Find MM. All I got to do is add 13.5 and 18.9 and then half that number, okay? That will give me 13.5 plus 18.9 is 32.4. And then halving 32.4 or dividing it by 2, I'm going to get 16.2, okay? This one also says find the mid-segment of YZ and the trapezoid PQRS. What we had to do first is be able to find out the maybe the lengths of the top and the bottom or the bases, or we could just find the distance from Y to Z. So Y is at point -1, 2, 1, and then Z is at the point 1, 2, -1, 2, 3. So I'm just going to find the distance, plugging that in. I'm going to do Z minus Y. So 2 minus -2 squared plus -3 minus 1 squared. That'll be 4 squared plus -4 squared, or 16 plus 16, which is the square root of 32. And then if I just simplify that, square root of 32, that decimal you can round up to just say about 5.7, okay? Next up is we're going to move into some kites. So a kite is a quadrilateral that has two pairs of consecutive congruent sides, but the opposite sides are not congruent. So it's good to draw these pictures here. Kite diagonals theorem just states if a quadrilateral is a kite, then its diagonals are going to be perpendicular. So let's make sure we draw that kite here with the perpendicular markings. And then the kite opposite angles theorem just states if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Like here, opposite angles are C and A. Those are congruent, whereas B and D are not congruent. Make sure you have these drawn on your theorem sheet, and then we're going to go ahead and try some examples together. So we're going to try to find the measure of angle C in the kite shown. Again, a kite is a four-sided figure, so I have 360 degrees, and right now I already have 130 of those degrees taken care of. So 360 minus 130, I'm going to get 230. But then I have to evenly split that between angle C and angle A, because I obviously know that this is a kite. B and D are not matching, which means angle C has to be equivalent to angle A, and since there's two of them, I'm just going to divide by 2. So I'm going to get 115 degrees for angle C. The next thing you're going to see is a flow chart of quadrilateral types. So we have all types of quadrilaterals. They fall under 3 categories: parallelograms, trapezoids, or kites. Remember, parallelograms have 2 parallel sides. Trapezoid has 1 parallel side, or 1 pair of parallel sides. A kite has 2 pairs of consecutive congruent sides. Okay. Isosceles trapezoid, the legs are the same length. A rectangle has 90 degrees and parallel sides. A rhombus has parallel sides with congruent sides, not necessarily 90 degrees. And a square has both of those things, 90 degrees and congruent sides. Okay, so what we're going to do here is talk about what is the most specific name for quadrilateral JKLM. The one thing we don't see is we know that one pair is parallel, but we can't use the term parallelogram because we need 2 pairs of parallel sides. So all we can do right now is call this a quadrilateral, because I know for sure that it is 4-sided. I just don't know if the rest of those are going to be congruent and parallel. Okay, so it's got to show both things. These we're going to try giving the most specific name, so using that sheet, we're going to look here first at number 8. Name each quadrilateral and explain your reasoning. So this first one, we're actually going to name it as a kite because it has 2 pairs of consecutive congruent sides. The next one, we do see that there is a pair of parallel lines, and the diagonals are not bisecting one another. So I would say this one's probably a trapezoid. So we have 1 pair of parallel sides, but diagonals don't bisect. If they did bisect, then we could possibly say it's an isosceles trapezoid. This last one, number 10, we know that this one side is 9, but doesn't match the other side. DE is matching FC, and EG is matching GC, but there's not enough information to continue with that, because remember, for your rectangle, we have to show 4 90-degree angles. The rhombus, we have to show 4 congruent sides, and we don't know if it's parallel or not because they're not showing 2 pairs of parallel sides, so we can just name this a quadrilateral. Okay, because we don't know about parallel sides, and we don't know about congruent sides, and we don't know about angles. Okay, that's going to conclude our lesson today on 7.5 properties of trapezoids and kites. Thanks so much for tuning in. Hope this video helped you, and we will catch you next time. Have a great day.